So today we're going to be looking at the valid parentheses problem. So you're giving a string S, which consists of these types of like bracket characters. So you've got the round brackets, you've got the curly braces, and you got the square brackets, and they all have opening and closing variants, right? So it's saying that the input string S is valid if and only if every open bracket is closed by the same type of closed bracket. So if you have a round bracket like this, it has to be closed by another round bracket. You can't close it with another square bracket. And then for the next point, open brackets are closed in the correct order. So if you have a nested one, kind of like this, like it has to be closed from the inside first. So like these two will be a match, and then it will match this and this. You can't have something like this, right? Because this is being matched with this, and this is being matched with this. And then for the last point, every closed bracket has a corresponding open bracket of the same type. So if you have a closed bracket, you kind of need an open bracket variant. Like the pair has to be complete, right? To really understand what's going on here, let's take a look at some example string inputs that could happen to you. The first one is just like this. It's pretty straightforward. This is obviously valid because the brackets are of the same type and then they're being closed by each other. That looks pretty good. Now we can move on to this one. This one's also valid because we got this pair, we got this pair, we got this pair. So that's looking pretty good too. Here's another one, which is more of a nested type. You've got this, which is a pair inside here, and you got another pair like these two, and then you got these ones, right? And then we can have an example that doesn't work. This is very similar to the example I just showed you, where you've got these two that kind of pair up, which is not the same type, so this is false. Not to mention the outer ones that don't match at all, but it'll already fail for the first set of pair. And then another one that we can look at is this, where we just have an open bracket with no closing bracket partner. This is also not valid. This one, we've got a closing one, just a single closing curly brackets. Likewise, it doesn't have a corresponding opening bracket, also invalid. This one is a little bit of a combination. You've got a curly brace, you've got this valid pair, which is cool, but this doesn't have a closing one. So that means this is not valid. This is similar where this thing pairs up, but we're missing a opening curly brace for this guy. So I think just through these examples, you have a pretty good intuitive idea on what constitutes as a valid input and what doesn't. Now let's try to solve this programmatically. So let's go through the nested input from earlier, because I think that's probably the best showcase for how this algorithm is going to work. So we're going to use the stack to solve this problem. The stack is going to be responsible for holding all the open parentheses we've encountered so far in order. So these guys. Because when we encounter a closing parenthesis, we want to find the most recent open parenthesis that we've encountered. So for example, as we're looping through the string with the for loop, when we encounter these open braces, we're going to add them into a stack and it'll look like this, right? For those of you who don't know, all the stack operations like peek, pop, append are all available natively with the list data structure in Python. So effectively, we're putting them in a list. So the first one is this round brace, second one is the square brace, and the third one is this curly brace, right? So this is our stack as we're reading that one by one. And then once we get to this, that's where it gets a bit interesting. So once we get here, we're going to want the most recent opening brace. And then we're going to want to check whether that opening brace matches the closing brace that we're currently processing. And if it does not match, well, then it would be a scenario like this, for example. Then this does not match, which obviously this would mean that it's not valid, right? But if it does match, then we'd have to pop this element, right? Because this open brace has been used. And by the time we get to this one, we don't want to pair this up with this anymore. We want to pair it up with this guy, which is the next most recent opening brace that's not been used yet. And this is going to be the same thing, right? Once we get to this element, it'll look for the most recent opening, and then it'll compare the types. And both of them happen to be square brackets. So we're chilling. And then we pop this, and then we move on to the last one, which is going to look for the most recent opening brace, find the match, all good. And then we'll pop it. And then that's the end of the string. Now, a couple edge cases that I want to bring up here. First of all, is the state of the stack at the end. So let's say we have an input that's like this. I'm just going to add like an extra opening circle. So as you know, as we're looping through this, we're going to add this, and then we're going to pop, pop, pop. And then once we get to the last element, we add this, right? So our stack is not empty. If we've completed all of the like popping stuff and we've reached the end of the input string, but there is still something in our stack, that means that we don't have enough closing brackets, right? We have an excess of opening brackets basically, which means that it's not valid. If stack is not empty in the end, that means we have an excess of opening braces. Scenario 2, if instead of having an excess open, we have an excess closed, what's going to happen? I added an extra closing bracket here. So as we know, it's going to pop all of this crap, and then it's going to get to this element. So it's going to look into the stack. It's going to grab the latest element of the stack, but the stack is empty because there are no more open braces. So it's going to error. So if stack is empty when processing closed bracket, then we have an excess of closed bracket or closed braces, I guess. Yeah, I think that's all we kind of have to take into consideration. So let's try to code this. So the first step, we do have to make a stack, which is empty for now. And then I want to define the pairings, right? The bracket pairings. So I'm going to have a dictionary where if you have a round open brace we want to match it with a closed round brace, and same thing with a square. We want to match the square with a square, and a curly with a curly. And then we're going to want to write a for loop that goes through every parenthesis in the input string. And then of course we have different logic depending on whether it's an open bracket or a closed bracket. So let's handle the open bracket case first. So how do we know if it's an open bracket? If p in pairings. So obviously if I do this check, it means that if p is a key in the pairings dictionary, that means it's an open bracket. So if it is an open bracket, then all we do is append it to the stack, stack.append p. Now, in the else scenario, if the pairing is not a match, how do we know if it's not a match? Well, in this branch, we know for a fact that the p that we're dealing with is a closed bracket. So we're going to say if stack -1, which is the latest opening bracket, if its corresponding closing bracket, so pairings of this, is not the same as the bracket that we're currently processing, then we're going to return false. Because then we have a scenario like this thing, where let's say we encounter a square brace, and then when we read the most recent one, it's a round brace. And it's like, okay, yeah, we're not a match. But this is also a good time to check for whether the stack is empty or not. Because remember, if the stack is empty and we encounter a closing brace, it means that we don't have enough opening braces. We have an excess of closing braces, right? So we're going to add that condition as well. If not stack, or otherwise, if the stack is not empty and the p that we have right now is a matching closed bracket, then we can safely pop the stack and go on to the next one. And I'm just going to clean this up a little bit. Instead of writing else and then another if else, I'm going to clean it up by turning this to an elif. And done. And then basically in this for loop, we're going to go through every element. And if it's an opening bracket, we're going to add it to the stack. If it's a closing bracket, we're going to do the whole popping thing. So in the end, if the stack still has elements, then what does that mean? It means that we have an excess of opening braces. We don't have enough closing brackets to kind of accommodate for it. So in that case, we're going to return false, right? Otherwise, if the stack is empty, that means that every bracket is successfully resolved. So in that case, we're going to return true. And then that's our code. Now we can simplify this a little bit further by just returning not stack, which is the same logic. And there we go. That's the code. If you're looking at time and space complexity, for time complexity, we're processing each element exactly once. And then all of the operations that we do in here are in constant time. So in time complexity, we have big O of n. And for the space complexity, we're using a stack, which we're going to put all of our open brackets into. So in the worst case where we have an input string with all open brackets, then it's going to be equal to the length of the string. So in the worst case, the space complexity is also on, right? Okay, bye.